Types and Frameworks categorizes virtual beings and digital humans by modality and underlying framework. It explores differences between movie-based static beings and real-world interactive avatars, and examines how frameworks for rigging, binding, and control determine controllability of models and chatbots. It introduces three main types of digital humans: CGI-based, generative AI-based, and mathematical model-based digital twins, while also mapping generative AI's role in producing media across images, audio, and services. This diagram defines the broad category of virtual beings, which encompasses three subtypes: static avatars, human-inhabited avatars, and AI-inhabited avatars represented here as virtual robots. Static avatars are the simplest form, existing as non-interactive or pre-rendered entities. Human-inhabited avatars add a layer of interactivity through direct human control, such as VTubers or performers operating digital characters. AI-inhabited avatars, or virtual robots, function autonomously, generating their own behaviors and interactions without human operators. By situating all three within the larger circle of virtual beings, the diagram emphasizes that they are variations of the same overarching concept, distinguished by how they are inhabited and how much autonomy they possess. This diagram, Virtual Being Modalities 15, Virtual Being Frameworks, compares four approaches to building virtual beings across four components: 3D model, non-standard rigging, missing binding, and chatbot engine. In the first case, end-to-end custom solutions are shown as fully blacked out, meaning they are not controllable by the user. In the second case, the 3D model is controllable, but the chatbot is not, highlighting partial flexibility. In the third, the reverse is true. The chatbot is controllable, but the 3D model is not. Finally, the fourth option, a DIY solution, provides both model control and chatbot control, though it often comes with technical challenges, such as binding and rigging issues. The framework illustrates how different setups vary in terms of openness, user control, and adaptability when integrating visual models with conversational engines. This diagram, Virtual Being Modalities 16, Different Kinds of Virtual Humans, identifies three main approaches to creating virtual humans. On the left, human digital twins are based on mathematical models that simulate real individuals for analysis, prediction, or replication in digital form. In the center, generative AI, commonly associated with deepfakes, produces realistic human likenesses and behaviors through machine learning, focusing on synthetic generation of faces, voices, and movements. On the right, 3D models represent CGI-based virtual humans, created through computer graphics and animation, often used in films, games, and virtual productions. Together, these categories illustrate the diverse technological foundations underlying virtual humans, spanning simulation, AI synthesis, and computer-generated imagery. This diagram illustrates a pipeline for generating facial animation from chatbot text output, while highlighting a missing step in the process. It begins with a chatbot API, which provides text, passed into a text synthesizer, such as Tacotron 2, to convert text into speech. Normally, this would produce an audio format, which then drives facial animation systems like speech graphics or Jali research to synchronize lip and facial movements. However, the red cross over the audio format step indicates a gap or inefficiency in the pipeline, pointing out that direct integration between text-to-speech and facial animation remains a challenge, as audio must still be converted into a suitable form for real-time animation. This diagram uses the metaphor of apples and oranges to distinguish between two fundamentally different types of avatars: CGI avatars and deepfake avatars. CGI avatars, like the apple, are fully computer-generated using 3D modeling and animation techniques, allowing complete creative control over appearance, behavior, and environment. In contrast, deepfake avatars, like the orange, are generated using AI techniques that manipulate or synthesize existing video and audio data, often superimposing or mimicking real human likenesses with high realism. By visually comparing them as different fruits, the diagram emphasizes that while both are forms of virtual avatars, they stem from distinct technological approaches and creative processes. This diagram defines virtual beings by emphasizing their distinction from both digital humans in movies and physical robots. Digital humans in movies, including deepfakes, are excluded because they are not real-time or interactive, while physical robots are excluded because they are not virtual. At the center are virtual robots, which qualify as true virtual beings since they are real-time and interactive, and can be either human-inhabited, controlled by people like VTubers, or AI-inhabited, autonomous, AI-driven agents. The red X's over movies and physical robots highlight that only interactive and virtual entities fall under the category of virtual beings, reinforcing the centrality of virtual robots as their defining form. This diagram, titled Generative AI Apps and Services, categorizes generative AI into two primary outputs, image and audio, and shows how they are integrated into different delivery models, apps and services. On the left side, apps incorporate both image and audio generation, providing end users with direct, often consumer-oriented tools like creative software, chatbots with voices, or visual design apps. On the right side, services offer similar capabilities, image and audio generation, but are typically provided through platforms or APIs for integration into larger systems, catering to developers or enterprises. The structure highlights the dual modalities of generative AI, image and audio, and their deployment, either as standalone applications or as back-end services. This diagram outlines the evolution of digital humans across three stages. It begins with CGI digital humans, such as metahumans, which are computer-generated and primarily used in entertainment or simulation. The next stage is generative AI digital humans, which operate in real time, using AI models to create adaptive, responsive, and interactive avatars that can engage dynamically with users. The progression culminates in human digital twins, highly detailed, data-driven replicas of real people, often applied in domains like healthcare to simulate, monitor, and predict human conditions. The flow illustrates a trajectory from static, design-based models to intelligent, functional counterparts that serve practical, real-world applications.